In this lesson, we're continuing solving our quadratic equations, but our special cases where b is equal to 0. So we're going to start with these review questions. So like here, these first two, where you're using box method to solve these, just multiplying. And then here is our factoring our special cases, right? So see how b is equal to 0, there's no x term. So this was going back to factoring our difference of squares, but also looking to see first if you have a GCF. So go ahead and pause the video and do these review questions on your own. And here we go. So here with the multiplying, right, you just have x plus 8 times x minus 8. So now I've got x squared, 8x, negative 8x, and then negative 64. So that's why here they cancel out, you get 0, and that's how we get that difference of squares, x squared minus 64, because the square root of 64 is 8. So again, notice here with that factored form. So then here, we have 2x plus 9 times 2x minus 9. So again, multiplying 4x squared, 18x, negative 18x, and negative 81. And then again, they cancel out, 18 minus 18, and you're just left with 4x squared minus 81. Notice now you had two perfect squares again, right? Because the square root of 4 is 2, and the square root of 81 is 9. Hence 2x plus 9 times 2x minus 9. So then going the other direction, this is just x squared minus 9. Well, the square root of 9 is 3. So this factored form is x plus 3 times x minus 3. Now here you do have a GCF. You were supposed to divide out 2. So now here, taking out 2, your greatest common factor, you have x squared minus 16. Now you can continue factoring because the square root of 16 is 4. So 2 times x plus 4 times x minus 4. Then here, you also have a GCF of 2. So you can divide both by 2. Now here you end up with 9x squared minus 25. Now are both two perfect squares? Yes, because the square root of 9 is 3, so 3x. Square root of 25 is 5, so 3x plus 5 times 3x minus 5. So now we're going to get into the solving our equations, but solving by factoring first. So we're going to first do this here, where again, b is equal to 0. We're going to solve by factoring, which means our quadratic must equal 0. So here, notice I've got my 2, my difference of squares, but first we need to take out our GCF. So here I've got a GCF of 3. So we're going to take out 3, and now we're left with x squared minus 16 is equal to 0. Now we can continue factoring, right? Because this is a difference of two perfect squares. So what is the square root of 16? 4. X plus 4 times x minus 4. Now we can solve. Now, if you recall what happened to our GCF, well, is 3 ever equal to 0? No. So 3 will just cancel out. So that's why you're left with x equal to positive 4 and negative 4, from positive 4 and negative 4 here. So then same thing, however, our equation, right, quadratic we're solving, must equal 0. So what do we have to do first? Subtract 164. Now you can subtract that from 2. They are like terms. So now we're going to solve 2x squared minus 162 from 2 minus 164. Now, do we have a GCF? Yes, we can again divide out 2. So now I've got x squared minus 81 from 162 divided by 2 is equal to 0. Now, do we have a difference of two perfect squares? Yes. We can take the square root. What is the square root of 81? 9. So x plus 9 times x minus 9. So now that means here, will 2, our GCF, ever equal 0? No. So 2 again just cancels out. And we are left with x is equal to -9 and +9. So you could see it written out this way or see it written out like this with our symbol here. So positive and -9. So go ahead and pause the video and try the 2 U tries on your own. And so now for the first U try, notice how it's already equal to 0. So now we can go ahead and start factoring. Well, we have a GCF of 2 is what you should have noticed. So after taking out that 2, now we're left with x squared minus 36 is equal to 0. Then you should have noticed you do have a difference of two perfect squares. Square root of 36 is 6. So x plus 6 times x minus 6. Then you should have said, nope, my 2 is going to cancel out, right? Because it's never equal to 0. And x is equal to positive and -6. Now in 1b, you should have noticed that you needed to subtract 29 first because the quadratic needs to equal 0. So you needed to factor here 4x squared, but now minus 16 from 13 minus 29. Now we can take out if there's a GCF, which there is. We can factor out 4. So now here we've got 4 times, that's just 1, right? So x squared minus 4, which is equal to 0. Now, do we have a difference of two perfect squares? Yes, because the square root of 4 is 2. So x plus 2 times x minus 2. Then when you solve, 4 is canceling out, and you're left with x is equal to positive and -2. So this is solving when b is equal to 0, we don't have an x term, by factoring. Because now we're going to get into the method of square root method. So again, you could go whichever way you want to solve these. It's just, again, this special case of b is equal to 0. So you could solve by factoring or solve by square root method. So like here, for example, we don't need to have the quadratic equal to 0. So how I think about it is, see how there's two terms, right? Because there's no x term, two terms, two steps. So if I have two terms, treat it like a two-step equation where we always add or subtract first, then multiply or divide. Now, because we have a quadratic, we are then always going to do the opposite of x squared, which is take the square root, hence the square root method. So like here, for example, we're solving for x. Well, I'm subtracting 24 from it. So I need to add 24 here to both sides. Now I've got 2x squared is equal to 24. We're still solving for x, but it's being multiplied by 2. Doing the opposite, divide now by 2. X squared is equal to 12. Now notice x is not by itself yet because it's x squared. So now what is the inverse or opposite of x to the second power? Taking the square root. So x is equal to positive or negative radical 12, which can simplify to 2 radical 3. So now here in 2b, actually, you know what, let me go back real quick so people can see how we get that, just in case. So like radical 12, I think about perfect squares. So a perfect square factor, well, 6 and 2, right? But neither are a perfect square. You could still continue using this for prime factorization, but you're going to see what I'm talking about here. Two other factors of 12 are 4 and 3. Now, are either of these a perfect square? Yes, the square root of 4. So I'm going to use the square root of 4 times the square root of 3. because what is the square root of 4? 2. So 2, then bring down radical 3. That's how you can get that simplified form here. Or you can do prime factorization. So same thing here. Again, we don't need to have our equation equal to 0. 2 terms, treat it like a two-step. So here, notice how we're subtracting 100, so we need to add 100 to both sides of the equation. Now I've got 5x squared is equal to 125. We're still multiplying x by 5, so the opposite is to divide. So now we're going to divide by 5. X squared is now equal to 25. So now here, we still have x squared, right? So the last step is take the square root. Now the square root of 25 is a perfect square, positive, negative 5. So go ahead and pause the video now and try these two U-tries on your own. And here we go. So here you are subtracting 96, so you should have added 96 to both sides. 6x squared is equal to now 96. Now here multiplying x by 6, so divide by 6, and x squared is equal to now 16, but this is not our answer because it's x squared. So now take the square root, inverse, opposite, and x is equal to positive and negative 4. Square root of 16 is 4. So then here, 2b, you are adding 15, so subtract 15 from both sides. Now I've got 3x squared is equal to 21. You're still multiplying x by 3, so now divide both sides by 3. And now I've got x squared is equal to 7. But again, 7 is not our final answer, right? Because that's x squared. So now take the square root. And here you've got x is equal to, can't really do anything with that radical 7, so leave it, positive or negative, radical 7. So now these last special cases of solving by square root method. See how now we have the parentheses? So this is all grouped together being raised to the second power. So I cannot do anything with this 10 until we get rid of the exponent. So again, what is the inverse or opposite of taking or raising to the second power? Taking the square root. So we are actually now going to take the square root first because of everything being grouped together inside. So we're going to take the square root first. Now here they cancel out, right? Because they're inverse operations. Now we're going to bring down x plus 10 because our exponent canceled out. Is now equal to the square root of 25, which is not just 5, but plus minus 5, positive and negative 5. So that means here, we technically have two answers, right, that we're going to be getting. Notice how we've always been getting two answers for our quadratics. So we're going to solve two equations. We're solving x plus 10 is equal to positive 5, but we're also solving x plus 10 is equal to negative 5. So no matter what, for both equations, we are going to solve for x by subtracting 10 from both sides of the equation. So now notice you've got x is equal to negative 5, and here x is equal to negative 15 from negative 5 minus 10. So x is equal to negative 5 and negative 15. So now here 3b. See how we're all grouped together, so I can't get rid of that minus 8 just yet. But notice what's on the outside, the plus 12 here, see? So first we've got to get this by itself. So if we're adding 12, do the opposite, subtract 12 from both sides. Now I'm going to bring down x minus 8 to the second power, which is equal to 21 minus 12 now, which is 9. So now can we add 8 to both sides? No, because of this power, right? See how it's all grouped together inside the parentheses? So what do we do to get rid of that? take the square root. That is your inverse operation. Now they cancel, bring down x minus 8, which is equal to not just 3, but positive and negative 3. So now we're solving our two equations. So the first one is just good old x minus 8 is equal to 3, but we also have x minus 8 is equal to negative 3. Now we solve for x. We're subtracting 8 in both, so we need to add 8. So x is equal to here, 11, 3 plus 8. Then add 8 here. Now notice we're not going to get 11 again because that's negative 3 plus 8, which is 5. So x is equal to 11 and 5. So go ahead and pause the video now and try these two U-tries on your own. And here we go. So here you should have noticed in the first example, you can't add 5 yet because it's all grouped together by your exponent. So the first step is now take the square root. Canceling out the operation, now here I've got x minus 5 is equal to not just 8, but plus minus 8, positive negative 8. So now the two equations you should have set up to solve are x minus 5 is equal to 8 and x minus 5 is equal to negative 8. So now here when you solve for x, you just needed to add 5 to both sides, getting 8 plus 5, which is 13. Then same thing here, add 5 from x, and x is equal to negative 8 plus 5, which is negative 3. So x is equal to 13 and negative 3. Now here, you had to get rid of the minus 28 because that is outside of this exponent here. So you needed to first add 28 to both sides of the equation. Now we've got our parentheses here by itself, x plus 9 to the second power equal to 49. But now you can't subtract 9, right? Because they're all grouped together. So you had to get rid of the exponent by taking the square root. Now we've got x plus 9 is equal to not just 7, but plus minus 7. So the two equations to set up and solve here are x plus 9 is equal to 7, and x plus 9 is equal to negative 7. So then as you go through and solve here, you needed to subtract 9, because that's the opposite of adding, on both sides. And x is equal to, that's negative 2, 7 minus 9. Then same thing here, subtract 9. But now you've got negative 7 minus 9, negative 16. So x is equal to negative 2 and negative 16.